Today we want to continue looking at some problems in our definite integrals chapter. And we're going to start with problem 3. I like problem 3 because it goes directly at what we were talking about yesterday in the difference between the left and the right endpoints. Now here is the thing that we don't like about the problem 3. This was a deliberate attempt to make this problem not a brute force problem. This one, you're supposed to react by saying, holy cow, too many subintervals. Because it's 30 subintervals. So if I just said, approximate the definite integral from 0 to 2 using 30 subintervals, that is an unreasonable question. But this question is not unreasonable because it says, find the difference between the left and right approximations if we were going to use 30 subintervals. So first of all, we want to approximate the integral from 0 to, let me look it up, 2 of this function. So we're trying to approximate the integral from 0 to 2 of e to the minus t squared over 2 dt. We want the difference between the left and right approximations when we use 30 subintervals. So since n is 30 subintervals, our delta t is going to be the difference in the endpoints, so 2 minus 0 divided by 30, or 1/15 of a unit. So if we think about a table of values, all that matters is what's going to be in first and what's going to be last. All the stuff in the middle will cancel out. All the stuff that the left and right approximations have in common will be canceled out. So if we imagine a table of values where we have t and f of t, we start off with 0 and e to the 0 is 1. And then we'll have 1/15, and then 2/15, and all the way up to 2, where we end up with e to the minus 2, where 2 squared over 2, so e to the minus 2. These end ones are the only ones that don't cancel out. The middle ones left and right have all these middle ones in common. The left approximation and the right approximation have all those values in common. So when we do left 30 minus right 30, those are all going to cancel out. The only ones that will be left are 0, 1, and 2 e to the minus 2. So we can calculate left 30 minus right 30. We're going to have a delta t of 1/15. And then the first left will be a 1. The second left will be what happens at 1/15, but the 1/15 will be what is the first right, and they'll cancel out because we're subtracting. So all the stuff that cancels, and then we'll just be subtracting e to the minus 2. So all we need to have is a 1 minus e to the minus 2 divided by 15. So all we need is 1 minus e to the minus 2 divided by 15. So 0.57, however many. 3 decimal places. So if we use 30 subdivisions or subintervals, then the difference between left and right will be 0.0058. We will be within 0.0058 of the actual value of the definite integral. Any questions? So in this problem, it's supposed to be shocking with this 30 subintervals. But the unshocking part is we don't want the left 30 approximation or the right 30 approximation. We want the difference between the two. So we could also, we do also want to understand that if I went from 30 to 50, I would take this difference and it would get cut in half. Sorry, 30 to 60. If I double the number of rectangles, I cut the difference in the two in half. So 60 would get us to be within 0.029. And if I cut this in half again at 120, that would get us to 0.0144. So if we think we need to be within 1/100th, if I want left and right to be within 1/100th of each other, then I got to have somewhere between, so 30, 60, 120, 240. So somewhere between 120 and 240, that's how often I would have to record the data. Any questions? The important thing here was looking what we were identifying correctly what we wanted to find, which is the difference between the left and right approximations. All right, let's pause the video here and check out another problem.